Thanks for joining us today. My name is Brett Philp. I'm one of the technical directors here at Densify. This is a Densify webcast on AWS, Azure, and Google, leveraging the full instance catalogs to the max. As a follow-on from our last webinar on using cloud instances effectively, the session is being recorded and will be made available for replay afterwards. We've got 30 minutes today with the Densify co-founder and CTO, Andrew Hillier. Andrew, thanks for joining us, who's getting through our content. I'll be watching the chat on GoToMeeting, so if you guys have questions as we go, please feel free to drop them in there. I'll keep an eye on it, and we'll try to get those answered before the end of the session. If we can't get to it, then we'll follow up with you directly afterwards. There's so many factors that affect customers and their need to consider in order to navigate the options available across the big cloud providers. Andrew, I think you've got a really interesting set of content today to dig in a little bit deeper in terms of where we left off last time. So let's jump in.
Okay, thanks, Brett, and thanks everyone for joining. I think we're actually kicking off the first thing with a poll, as we did 2 weeks ago. So we'll just bring that poll up, and I believe we can see the answers as they come in. Although I can't visibly see the poll, but I think it's,
which cloud providers are you using? You can select more than one. AWS, Azure, and GCP are the big three. So just go ahead and click, and we'll leave it open for about 20 seconds here.
Yeah. And again, we do find a lot of people join our webcasts more for education and maybe aren't in the cloud yet, so not having any as a financer as well, or on the way. But again, we do see a lot of companies using more than one cloud, which I'm sure we'll probably see today as well.
Just leave it open for about 5 more seconds, and then we'll close it down. Wow, it's an audience today.
Either it's a very shy audience or a very Azure-oriented audience. Luckily, the content is the most detailed on Azure because it's kind of, the catalog is very interesting. But we'll be covering Amazon and Google as well. All right, so let's dig in. As Brett mentioned, we did do a webcast 2 weeks ago. This slide is a slightly updated version of what we used to kick off that one, so I'll just cover this one quickly. And it's really just kind of an overview of the catalogs over time for the providers, and it's an interesting way to look at it. It's almost like a pyramid, or maybe a Buddhist temple in this case, where Amazon started off with a very small catalog. This is just from 2013 onward, but they started off just with the M1, and then they constantly expanded up to the point where now there's 77 different families and now 7 generations. So there's actually now a 7th generation. So they've done a pretty good job of moving forward and bringing out new generations quite regularly, and they have a lot of different options. And you see the 77 kind of there at the bottom. So some of them are highly related to each other. They're just slight variants, like they might have disk or not, or better networking. There's really kind of 39 different flavors overall. And again, I think this is great because this means you've probably got the right instance type for almost any workload. I mean, burstable, all these things. But as we'll talk about, it's pretty hard to figure out which one you should be using. And that's kind of what this is all about, is how do I leverage this full catalog, especially because I might be currently on older things. So last week's webinar was all about that bottom slice, all the latest stuff. We're going to go back through time a bit today and talk about, well, maybe you're on an M3. What do you do? Because we see a big mix in use in customers, both the types and the ages of the instances. Azure, a little bit different. This is actually, if you look at the numbers, a little bit more, 644 as opposed to 489. Coincidentally, there's also 77 VM families. That's probably just a coincidence. They're up to V5 now in their generations, and really 43 distinct types of things in there. Some of them are variants, like there's the Ds are pretty common, but there are Ds that are high memory options as well. So it's a little more wordy in the way they name these things. It is pretty complicated to navigate their catalog. I'll go through this in some detail as far as how to move from a V2 to a V3 and what that means. And this complexity is critical, because if you can't figure that out, you can't leverage these catalogs. If you can figure it out, of course, then again, there's the perfect tool for the job in these catalogs. They've got something for every kind of distinct workload. Google took a pretty different path. I think they had mercy on us for several years where they only had 29 types. It's kind of interesting because underneath that there was more types than that would imply. They just kept calling it the same thing. So the N1s, I'll talk about this in detail. The N1s, there's actually many different types of N1s on completely different processors, but they're all called an N1. There's a blog post where there's a funny joke. It's like Henry Ford. The author quoted Henry Ford saying, "You can have any type of instance you want as long as it's an N1." So they kind of carried that along, and they started expanding more in recent years. But there's a little more complexity because, again, you see down at the bottom, the N1 has an asterisk because, again, there's a high memory N1, there's ultra memory, there's different configurations. So an N1 can actually be effectively compute optimized or memory optimized. And there's also some of them have custom sizes. That's a little cross. So we've seen customers leverage that. That can be tricky. You can kind of give it any CPU and memory configuration you want. Sometimes it doesn't make sense. Maybe if you give a lot of memory and 2 CPUs, it might end up being more expensive than just buying a normal instance with that much memory. So there's all kinds of points where it crosses over and certain decisions make sense and certain ones don't. And it looks quite a bit different from the Amazon and Azure catalogs. And I'll dig into all these things in a little more detail. Now here's a slightly different breakdown. This is by who focuses on what. So if you look at the different types, the very broad strokes like general purpose versus compute versus memory. For example, we see Azure seems to have many more options for memory optimized than the other providers. Amazon seems to have more compute optimized options than the other providers as well. And then again, there's different flavors. There's burstable. That's not really broken out here, which might make sense for certain workloads. And sometimes you can enable specific features. And I'll talk more about this as well. Sometimes you can just get a certain type, but you can actually request that it be a different processor, as an example. So it's useful to know, that's kind of really in the footnotes. And the footnotes are almost like what was on the previous slide. Each provider has their own little considerations where, again, you can actually go and pay the same price, but ask for a later processor if you know to ask. And so there's all kinds of little caveats and gotchas in there. And also a big one is they vary by region. So, you look at the complete catalogs, well, not everything is available everywhere. And you see, and they covered that on the last webcast was a little bit more around the latest stuff and, when things tend to come out and which regions get them first. And so, Northern Europe may or may not have a certain type of thing that's available in Ohio or maybe coming next month. So that's also very important because you can't leverage it if it's not available to you. And it's extremely complicated to know out of all of these things which are available. Because if I drill in just on this one bar here, it's like 337 different memory optimized options in Azure. And so just to give that some scale, if we count, there's the DS11s and 12s, those are Ds, but they're actually memory optimized because they're not like a D1 through 4. E's, G's, M's, I don't know. So, oftentimes we're using our analytics and it'll give a certain answer and people say why, and I'll say, I don't know, like this is the algorithms figuring this out because this is so complicated. Like, how do you know an M6 64DS V4? What does that even mean? What does it have? What does it do? So that's kind of part of the whole theme here is how do I leverage that list? If I can make use of that list, it's very powerful. If I can't, then you're kind of stuck. And I think that's, I'll cover that later. That's what we see organizations where they just get stuck on older things because they don't know how to move to newer things, or they're on the wrong type of thing. They're on CPU optimized when they should be on memory optimized. We see that a lot in container environments where oftentimes memory optimized is a better way to go, but they might be running scale groups on compute optimized. So I think I made the point. It's very complicated. I'm going to make that point even more now with a kind of a walk through time. So let's just start off with, let's just say I'm running on a standard DS4 V2. It's a pretty common. The Ds are pretty common out there from what we see, and it's a V2, so it's a pretty old generation. And I want to optimize this. So there's probably something better in the Azure catalog than that one, especially just given that it's so old. And so if you kind of walk through this, methodically, this is an 8 by 28 in that case, in that generation, at 28 gig of CPU of memory. What can I go to? There was a DS4 that did exist, but that's older, so we're not going to go backwards. There might be some really bizarre reason why you might want to, if it's super cheap, but otherwise you're probably not going to go backwards. What about a DS4 V3? You would think because we have a V2 that implies the existence of a DS4 V3. No, that actually didn't exist. So there's a bit of a problem here. It's a bit of a nomenclature problem, but it's kind of also just the way it was designed and evolved. There is no V3. There's a D4S V3. So okay, the S moved to the other side of the number, and it's lowercase now. But that's only 4 by 16. So for some reason, that thing is not the same ratio of CPU. The other one was, it is the same ratio. It's 4-to-1 ratio. It's just half the size, even though it's a D4S. The D8S V3 happens to be the one that is the next progression of a standard DS4 V2. So confused, it gets much worse than this. And this is a kind of a known issue. We have Azure customers that try to navigate this. Analytics are obviously a much better way than trying to do this manually. And so now we're on a V3, but we know they have up to V5. So what about a D8S V4? Is there a newer one of those? Because I don't want to stay on something really old. Well, that thing lost its disk. For whatever reason, the D8S V4 no longer has a local disk. So if you're using a local disk, you don't want to go to that one. There's a D8DS V4. And so, the bit of a pattern there, the D means there is a disk, although the 3s didn't have a D, but they had a disk. So that one, yeah, that actually would work. What about a D8DS V5? Now, I'm kind of scared. What about that one? What's changed? And that one actually works. So that's, okay, phew, we made that last step. That's a good step. Or did we? Because this original thing had 32 data disks up to maximum and up to 8 network adapters. These ones only have half that. And we've actually seen this be a constraint in a customer where they were maxing out the data disk. So you can't actually go to that new D8 because you can't have as many disks anymore. So it's a bit of a minefield. Now, again, so when we're on the theme of leveraging this to the max, you got to be able to navigate these things and understand what you can and can't do. And this is just one type on the same instance family. What about other instance families? There's burstable, there's memory optimized, compute optimized, and we find in our customers a lot of times the most of the workloads are actually on the wrong type altogether. They're not just the wrong size, they're on the wrong type of the wrong family type. So it's extremely important to look at these ones, but it's even more complicated because they have their own set of gotchas and rules. So there's another flow chart probably for each of these that's as complicated as this one as far as what I go to, and it's just getting worse and worse over time. So this, and viewed optimistically, it's getting better and better because there's more and more options. You're going to find that perfect option for your workload, but it's getting harder and harder to figure out exactly what you can and can't do. So, just to put this example in perspective in analytics terms, so what this would look like in practice if you were to analyze this kind of more methodically, letting the machine make decisions, is, we would start by looking at all the utilization patterns and come up with what on earth is this thing doing? CPU, memory, I/O, and in this case, we're looking at the CPU, and it's in benchmark terms. So we understand not just as a percentage, but this thing's using so much horsepower because the newer instances might have faster CPUs or other things. So I need to be able to account for that, and you need to do that across all the different types of things. I'll talk about why in a second. Obviously, CPU and memory, but I/O is important as well, because maybe it's okay to lose your disk if you're not using it. So this is all kind of the starting point is let's understand what the things are doing, and then let's take that and analyze it against the catalog. And again, these catalogs are huge, so this is just a small section of the Ds. But if I have the workload curve and I have some other information about what this thing is and how it's configured, I can run rules against it to understand what I can and can't do. So we might say this thing's production, so I want it to run not very hot, or it's dev, I want it to run really hot, or I have certain limits on the I/O, or again the number of disks. Maybe I have a trouble. Maybe it's 32-bit, or maybe I'm using para-virtualization. I can't move forward. Whatever the case is, there's all kinds of considerations that dictate where this can go. And the bottom ones are very important. That AVX QAT, those are Intel features like vector extensions and quick assist, which is cryptography. If I'm using that, I definitely don't want to lose that in what I'm doing. If I'm not using that, I might want to use that because the thing will work way faster if I can leverage that. And the catalogs contain instance types that have those features into them. You know, maybe it's the latest Intel gear. So all of these things kind of get thrown into the pot. And when you do that, you can score and say, okay, on that particular, sorry, they're cut off. They have such long names in Azure. On that instance type, it doesn't score well. And we can score the entire catalog for every workload and say, okay, this one, when you run the numbers, it's on a DS4v2 and it should go on a D8 DSV5, which is that flowchart from the previous slide. So, and you see there's not a lot of green here. Those green ones are all options. And then when they're green, the ones that are the lowest cost are the tiebreaker. So you want to choose the one that can run it for various reasons at the lowest cost, get the best price performance. And again, back to that other example, if we say, well, you know, this D8 SV5 is scoring quite low. And that's the rule engine picking up and saying, well, you're going to lose your disk. So there's a rule engine under the covers looking at all those considerations I was talking about and say, yeah, you can't do that option. You're going to lose your disk. Or again, if you're not doing much I/O, then maybe this rule doesn't fire. So it can get pretty complicated. You know, you see also here it's noting that you change sorry, there's a family newer generation. So you're going to a newer generation, which is just a 2%, means just make note of that. It's going to report that, by the way, you are changing generation, but that's fine. If you were to go backwards, it would probably be a big penalty. So there's detailed rules that codify all those things I was talking about. And I can't underscore how important this is.
There's a lot of customers that, you know, they look at the recommendations in Densify and they see these effort rules that the engine is automatically considering to determine the best fit. But there's always, I'll call it, you know, business nuances or preference of, you know, I want my things to be treated differently. So being able to tune the engine as well is often an important factor.
Yeah, that's a great point. I mean, everybody's special in their own way, and it's true. And ideally, you want the rules to be common as much as possible. But we do see variation, and a lot of our customers do have multiple types of rules that apply. Compliance, or, you know, if you have load balancing pairs, something's supposed to be empty, it's supposed to be idle. You got to take that into account to get the right answer. And I want to stress that right answer thing, because if you get this wrong, you will generate a recommendation that when somebody does, will blow up something, an application, maybe a really important application. And I want to put that in context because, you know, we do a lot of stuff like FinOps Foundation, and I'm sure people on this call, it's probably more of a DevOps crowd, but if you're familiar with the FinOps Foundation, you know, here's one of their polls, which I found quite interesting. What's the biggest unsolved pain from a FinOps perspective? You know, when you're talking about the finance side, they identify that getting engineers to take action is the biggest pain. Now, I don't think everyone in that kind of financial side understands why an engineer might not take action. I think some people, for example, you know, Brett and I were joking about this. We were on a session where somebody was saying, well, you know, if you want the engineer to take action, you have to actually code it make it like a coding challenge for them, and then they can't help themselves but do it. And I'm thinking that is so naive. That's not why an engineer doesn't take action. They won't take action if they think the answer might be wrong, because they are responsible for that application running. So if you give a recommendation, you know, a simplistic recommendation that doesn't take into account all of these rules, you know, that we're talking about here, you will get the wrong answer. And then there's a trust factor. If you only get so many wrong answers before you don't do it anymore. And so we've seen customers using other products where they say, we have a database full of recommendations we can't take because they may not be correct and we don't have time to review them and nobody trusts them. So I want to underscore this, getting this right is absolutely critical. And in the spirit of leveraging the whole catalog, if you don't get this right, you can't leverage the whole catalog. You just get frozen into some corner of it because everybody's too scared to make changes.
One of the things we like to do with customers out of the gate when they start using Densify is to start small, start safe, build that organizational trust around the recommendations you're taking. A lot of times we get feedback from the engineers, they don't want to take those kind of actions because they're not the big bang ones. They're not the ones with the big attractive savings, but it's about learning the process of change and getting comfortable with change to the point where you can automate it and have that confidence.
Yeah, and a byproduct of these rules also is what we call an effort ranking. So you can actually do an effort versus reward and say, well, that change is easy and it's big impact. This other one's a hairball and it doesn't actually save that much. And Brett, again, you were mentioning that being a big thing. It's in customers, they don't want to waste their time on things that aren't effective. They only have so many cycles. And just to kind of complete this kind of run, over time, this might change. We might find that the workload grows, and now when we reanalyze against the catalog, none of these are options anymore. We have to go a little further afield and go to, in this case, an E8DSV5. So that cross-family thing is very important. We want to be able to go to newer things safely, and we want to be able to go to the right family safely, but going cross-family does require rules to make sure that the other family type does give you what you need. And so that's why a lot of products can't recommend cross-family, because it takes too many, it requires rules that they just don't have. And so those rules are critical to coming up with those answers. So I'll just go through Amazon and Google at a slightly a higher level. Amazon, the catalog is well organized, but the devil's in the details. So let's say I'm sitting on an M3. It's a 4x16. There was an M1, but that's, we're not going to go back to that. It's only available in certain accounts. M2, the M2s are kind of funny. You would think, that seems similar. It's still older. Those are kind of gone, because in the early days, Amazon, rather than going to, that was a high memory instance, but they used the same M designation, general purpose. So they even got it a bit wrong early on. They ended up using the M's for high memory instead of just for general purpose. They got out of that and kind of, discontinued that. And then they started to say, okay, on the M4s, that is going to be a continuation of the M3. But now the devil's in the detail. So it's not cut and dry whether you can use it or not. If you're using pair virtualization or classic networking, you can't just go over to an M4. There's some changes required. You do lose a local disk as well. So then it becomes a function of the I/O. So the analytics will check and say, well, are you doing much I/O? Because if you are, we're going to say don't go there. If you're not, then maybe it's a recommendation. And to Brett's point, that can be tunable. So that could be an option, depending on the circumstances. Then we get into the 5s, where we start to get a little more that pyramid expanding, where there's a M5 extra large. It requires a different AMI. So sure, you can go there. It requires something else. The M5ZN, that's a fascinating one. That's a fast per core performance and faster network. It's actually faster than some of the Cs for CPU. So it's a funny beast. It actually might be a good choice for all kinds of things. This one has a local, the M5D does have the local disk, and the DN is disk and networking. And then we get into the 6s. So now there's an I, which is the latest Intel stuff, and that has AVX and QAT and all those lovely things, but doesn't have a disk. Again, you kind of see here, this is still very complicated. The GD does have a disk, but it's graviton related, so you can't just take whatever's running on your M3 and run it on that. You use a different instruction set. So there's a bit of a challenge there as well. And then, of course, there's all the other variants, T, burstable, and compute. Again, and it's getting more and more expansive, which is great, but challenging. And there's also, again, the regions. So not all of these are available in all regions. We were doing an analysis of the M6Is and the Ice Lake, which is fantastic. Not quite available everywhere just yet. But if it's in your region, use it. And again, last week's webcast, or 2 weeks ago, the webcast covered that in a little more detail and some of the price performance options around that. So Amazon, kind of more intuitive structure, because the numbering and stuff is a bit better, and the families are laid out better, but there's still a ton of considerations when you try and navigate and maximize your use of these options. And GCP, and I'm just watching the clock here so I don't run too long, the N1 is kind of forever it was all called N1, but it has 6 different processor options, and you can actually ask for a processor in the UI. You can go and say, I want Skylake, and if you get Skylake, then, for example, you get that Intel, the AVX 512. You can just ask for it. I don't think it costs any more. You just have to ask for it. N2 was kind of their newer gen, which has still multiple processor options, and they actually cost pretty similar to an N1. So there's not really any reason not to use them. So it's again, it's a bit of a minefield. There's just some logical choices that need to be made. There's the Tau and the Cs, compute optimized. They're a bit of a minefield too, because the C is newer and costs a bit more, but the T's are actually faster because you get a full core. There's no hyperthreading. Again, there's all these details. So one choice might be better because there's actually, you get an unhyperthreaded core when you get that one, and so on and so on. And again, there's a blog post on this that's pretty interesting read on all the complexity around the Google compute engines and how to optimize them given all their options. So with that, let me just kind of close off on the bottom line here. I think more choice is good. It means you can, if you've ever been shopping for a car, the more options, the better. You can find the exact one with the exact trim that you want. And I'll just show this example of, if you really get it right, and we do a lot of R&D with Intel, which Brett will cover in a second. If you run the latest, like the Ice Lake chip, if you get instance with that, and you're running the right SSL driver, if you have Nginx workloads, they work way faster. So if you make the right choice here, huge gains, but it's complicated. So we actually see people that are not anywhere near that. They're even just running the wrong types of things, compute optimized when they should be memory. People are running old, I'm just going to go quickly here. They're running old types because they're too scared to get on the newer stuff. And a lot of simple tools can't do what I showed earlier. So they don't even give recommendations to go newer or different because they don't have the rules to be able to figure that out. What this means is that the DevOps teams, I'm sure some of you on this call, you're distracted thinking about resourcing when you should really think about features. And to Brett's point, it's very difficult to assess which things you do tackle because some of them give more reward relative to effort. And so, taking more of an analytical view lets you do that. And of course, even if you do it right, you got to do it again and again and again. So this is kind of a moving target. So we would say it's critical to be methodical, scientific, and look at all these details. And then you can kind of leverage this whole thing, this whole provider catalog to the max. I love the stoke factor of the title of this webinar, to the max. So anyway, that was quick, but we have a couple minutes left. I'll turn it back over to Brett, and hopefully we still have time for some questions.
Awesome, absolutely, Andrew. If you want to go to the next page, just talk about the fact that there is an offering available to help customers with picking the right answers. This is a program that we have with Intel called ICO, Intel Cloud Optimizer. Essentially, it's Densify under the covers, paid for a full year, sponsored by Intel, and includes expert assistance from Intel to help determine the optimization answers that you want to use in your business. Great no-risk way for companies to try out the software, see what the size of the opportunity is for your particular infrastructure that you've got deployed, regardless of where you've got it deployed. There's a little QR code that folks can scan to jump to more information about ICO if there's interest. With that, Andrew, I'm going to jump back to a couple of questions, if you don't mind. I'll just take a minute or two on those. Here you go. How important is it that application type be considered when picking a cloud instance?
So that's an interesting question, and that's some research that we're doing. So I think there's low-hanging fruit in just getting it right without knowing the actual application. There's kind of an approach where the numbers reveal quite a bit, especially if you need to make something bigger. And so with the right policy, you get very far. But when you know what the application type is, you can take it even further. And I mentioned things like AVX and Quick Assist. Those features, certain applications can really leverage those. So if you see a TensorFlow running, for example, the AVX 512 makes it 4 times faster or something. So it's a huge gain. So I think it's, there's an element of it where you can do it without deep introspection into the applications, but having that visibility lets you go even further. And that's a big focus for us right now, joining with Intel on that type of thing, to make sure that if there's a specialized feature that you can leverage, especially if you're already paying for it, you should be leveraging that. And so I think it is a very interesting question. It's not absolutely mandatory, but it's really useful to factor that in as well.
So by default, you get optimization, and with Intel's contribution, you get optimization plus. Let's come up with a name for that.
Yeah, it's nice because it's not just maybe 10, 20, 30% faster. It's like 4 times faster, like things like Nginx or TensorFlow. So it's really a kind of a step function different if you can leverage those features. So absolutely. But again, even just having this straight up data, not knowing what's running, we find huge opportunity in a lot of customers simply because they're just not even running the right type of thing. Like they're just not, the CPU to memory ratio just isn't correct for even just what's happening, from a black box perspective.
Mm-hmm. What's the suggestion if you don't have memory data, which seems to be a common thing for customers?
Well, that's a good point. So again, that's in the progression. Knowing the apps is great. Just not knowing, but knowing the workloads is great. A lot of times we do see that memory data isn't available. We can pull it from Splunk and other products. We're very opportunistic when to pull data from different sources. So there's sometimes ways to get data around that if it's not enabled in the provider. But if we don't have it, we just fail safe and say assume it's using all its memory. So we find that even with no memory data at all, you get a lot of recommendations out of the analytics. The recommendations just leave the memory the way it is, but focus on CPU or IO or other things. So Even in that case, we see that there's a whole lot of optimization potential, within the absence of memory data. Of course, if you have memory data, then you can get even more optimization. But again, like you mentioned, a lot of times we see it's not available, and that's fine.
Okay. Perfect. With that, I think what we'll do is, Andrew, if you want to flip to the next, I think the last chart, we'll just do a bit of a preview of our next webinar if folks are interested. We're going to be doing a talk on continuous optimization, so the automated application of optimization against the infrastructure using Terraform. It'll be a live demo, so we'll get to see Densify's recommendations in action. So hopefully folks can join us for that on May the 18th. With that, I'd like to thank everyone for joining today, and Andrew, thanks so much for doing this.
Yeah, thanks everyone.